So if they've ever asked you that, it's saying integral. Right, so that represents the integral. These are your lower and upper limits. And this is the main function. So in terms of a visual thing, back to our x squared, right? That would be the starting value, whatever it is, a, b, and that's f of x. So this is saying I'm going to anti-differentiate this function between the numbers a and b. And what it's getting for me is an area. How do you do this? What you do is you anti-differentiate. So f of x is the antiderivative of f of x. Like we did with our example here. So 1, 4, x squared dx. Right? That corresponds to that. I'm drawing the graph from 1 to 4. I'm trying to work out the area under x squared dx. So the next line is x cubed on 3, which is what capital F of x would be. Guys, distracting. So x cubed on 3 is capital F of x. My 4 and 1 have moved because they're my a and b, so all I do is move it from the left to the right. Yeah. That corresponds to that theory line. And the next line says, how do you actually work it out? Capital F of b. Well, in English, that means stick b into your function. You know that function notation. So that is 4 cubed over 3. Right? F of b means I put the 4 into my function, minus f of a, which means I put the 1 into my function. So that's the connection between what I did over there before as a quick example and what we call the fundamental theorem of calculus. And then you evaluate that. We did that before. We came out with 21 square units. Now there's a bunch of relationships that we need to be comfortable with and know, and I'll do that in a second. But the idea now, going forward, is when we're asked to find an area, or when we're just asked to evaluate a definite integral, you are now getting a numerical value at the end. Okay, you're not getting any x's and c's and anything else, you're actually getting a numerical value at the end. So that's the difference between definite integral. I've got numbers. Hey, you give me numbers, I give you numbers. You give me letters, I give you letters. It's as simple as that. If I didn't put these in here, you would just anti-differentiate. Get letters, variables. If I put numbers in there, you're going to give me a numerical answer. Huh? Quite straightforward. We have to then connect this to areas, and we'll do that in the next